So here we have the symbols. Okay, so here we need to understand the outline. Okay, so whatever I showed you, right, in the CANoe, so you will have an option. So when you go to the CANoe, under home, we have a panel. From here, we need to create a new panel. Okay, so when you do the new, this other window will be opened. So what will happen exactly here is we have the uh, outline. So whatever the functions we are able to take, so that functions and these symbols will be visible here. And next we have the functions like similar to the CAPL, where we have the symbol explorer. So here we'll have the properties and the tools and project management. So it is kind of the same for any GUI we need to create, like hill or hill DSpace or control desk, or similarly NI lab view and opalati, some other GUIs are there. So where if you need to use the GUI in the embedded system, so mostly the input, whatever we are giving, it will be varied. Okay. So the input, if you take, like I need to give the um, LED. Okay. LCD is the one control where I need to give this LCD control. And we have the meter. So the meter is where you need to, uh, whenever this is a kind of a analog, and this will be the part of a digital. So whatever the duration it is making in the analog, so that digital information we can see it here. Okay, so and how we are able to see the digital information here? So just you need to under the tools, so you can drag and drop it. Okay, so these are the options, like these are the some standard things we have. And we need to add any additionally the graphical windows are there, and moreover the complex data, to where you need to see the multiple data here, like whatever the data you are able to monitor. So just you need to consider from here also. And parallelly, like we have a special like suppose if I am making right the programming of the CAPL, so those things we can drag and drop whichever we required. Okay, so and they will the file media play. So some video you need to make it a view on this. So just you can drag and drop here, and we need to configure it. Okay, so the configuring is the other activity. So because it is only kind of no connection. When you do something, it won't have a proper connection. Okay, so for this, what you need to do, just you need to right click. Okay, so right click and you need to attach the signals. So this is one option. From this you can do it. And the other option will be like right click uh, and show the properties. So mostly the properties will come here. And the other option, if you click on this, and it will redirect to the properties. So here you can attach. Similarly, whatever the options we are able to see, attach signals, attach variable, detach signal. So this reset values, all this can be able to see here. Okay. So now I don't want the color. Okay. So it's showing that alarm display. So it is a false, like where I need to make it a true. We can change it. And next part will be the lower limit. So I need to give the values of for this lower limit. So just I'm making a 45, and the color is specifically we need to give it the color if I need to change. And here the upper limit means whatever the red one you are able to see, that will be the upper limit or lower limit. So just can change it. And the front angle, so what is the angle? It have a minus 135 to plus 135, that is angle. So you can change if it is needed minus 182. So this is requirement. Okay, so if the requirements are like this, so you are able to adjust it. So it is 180 180 plus both minus minus of 180 and 180, it will be a plus, so it will be the 360 it is covering. Like you don't want to give, so just you need to give minus 90, and plus 90 means it will come as a 180 angle. So just you can customize your panel accordingly your requirement. Okay, so and next will be here we have the signal mapping. So signal filters where you can give your signals like whether it is a variable or the signal. So what is a variable? What is the signal? So I will tell you this. Signal is specifically it is reading of the uh, specific information, means whatever the message can message it's carry, right? So that will be a part of the message signal. And variable is the interface from the GUI. Okay, so that will be a part of a variable, and that these variables will be accessed from the DBC DBC file, and moreover, some of the system variables and environmental variables will be there. Okay, so based upon that, it will be accessed. So how I am able to see those information? So here we have the system environmental variables and system variables. So based upon our requirement, I need to map this. Okay, so I need to map this signal. So to this. So what is the purpose when we need to use all those information we need to know like before doing this configuration. Okay, so for understanding this panel creation, we need to know a few things. So this is a final, like once if you create the panel and save this configuration, like I assume that my configuration is saved and it will be saved under desktop. I will make it as a desktop to you to show how this panel will become. And this configuration will be saved in a form of .xvp. You can write down panel design will be created under a format of .xvp. Okay, now I created a panel on desktop. Okay, so it saved it. Now I am closing this my requirement and I will go to the again the panel. Okay, so whatever the panel I created, so it I need to access it on the tool. Okay, so just go here again from the layer panel. So I need to make it see like this is the latest one I created it, panel one. So now I need to do it. I need to add whatever I created, right? Now I need to add to the CANoe. So just add the panel. So go to the desktop under this. Okay, so like usually it will come like this. So for backend to know understand what are the parameters, what it is connected. So here if I need to again add or new, so this will be the new, and mostly the panel creation is a part of a GUI where we are interacting with the ECU. Okay, so now we need to understand what these are part of the environment. Okay, environmental is where we are able to access the information. Okay, so what is the environmental variable? So environmental variable is a global and can used in every network node. Okay, so in the CANoe configuration, you can write down the point global, global and can environmental variables. So we can use everywhere in the network node in a CANoe configuration. Means it is a global throughout the meaning of the global is where we can access anywhere. Okay, so and it create the communication between the panel and the CAPL. Like if we are making the programming right in the CAPL, so from the CAPL programming, so on the panel GUI, it may interact you this with the help of environment variables. And moreover, whatever the panels we are creating, we are make it. It is a part of a dynamic control. Okay, so means where we can make the seat arrangement or some adjustment we are doing with the help of this dynamic control. And moreover, uh, means on runtime, like you will need to operate the car or something need to start. It is a part of a dynamic activity. So that you are doing on panel. And simulation capability, so what are the simulation you if you need to do such kind of simulation, means like you the seat control or some part of visualization you are doing, right? So that will be a part of a simulation. We don't have the real hardware, but instead of that we are seeing the visually it in terms of simulation. So here specifically it should make the ECU or the controller or the node. So need the comments. Who will send those comments to the ECU? So from the CANoe on the panel. Okay. So in the CANoe panel, we have a comments. From there, we are sending the information to the ECU. And whatever the messages or the commands that we are sending from the CANoe to the ECU, so that will be all part of the commands or the messages that we are sending continuously. Okay, and next will be the part of the buttons, whatever the buttons, like we able to create the buttons and LEDs. All this will be a part of a simulation. And moreover, network nodes and even the messages I need to send continuously multiple times. So yeah, we can do it on this, and we can perform the diagnostics and the operations, and physically we can change the values. Instead of values, we can make the buttons and do the on and off. Okay, and moreover, we can see the uh, graphically the signals values also, like the sine waves or the square waves, how it is impacting. Okay, so like how this environmental variable will be accessed. So let's take the example. So here I have a battery. Okay, this is my battery. This will be a part of a environment variable, we say. Okay, why we say as an environment? Because it is out of scope, right? Like we are simulating it, but the battery will be the part of the hardware. Okay, so and this will be the environment variable. So now whatever the message means, the specific message, the battery will read the switch. Okay, so and we are giving this dot battery signal, and I created another programming. So here, so battery message dot signals and get value of this. So this message battery will be written here and output. So this will be a switch here. So whenever the battery you need to turn on, you need to activate the switch, and the battery will give the information. Means the battery will be activated. Okay, so if you turned off, the battery will be off condition. Screen. Yeah. So it will be like this, like where we need to understand the flow, how it should be communicated. Okay, so like this CANoe graphical windows are very useful because it will help us the visual events by recreating the uh, dashboard console and switches and lights and so on. So not only like this, so we can create in between the light. Okay, so and make if you turn on, the variable should take the uh, means whatever the LED is there. So when the LED is interacting with the real hardware, how the power is consuming, same behavior we can observe in the CANoe simulation tool. So that visually simulation we can make it in the CANoe, but we need to understand how this communication is happening. Okay, so next is the behavior of the network node. This like we need to understand whatever the external, these are the external inputs. Okay, so the behavior of the network nodes with regard to the external input and output signals is described by the special variables called environmental variables, such as the position of switch. Okay, whatever the switch position we call as the input and output of the things. So it will give the behavior, right? So like this all will be part of the environment. Means we required the switch position as the network message. Okay, so as I told you, right, we need to map when we are creating this tool. We need to map the messages and signals, but specifically we need to map the environmental signal. Okay, so you can write down the behavior of the network node, the behavior of the network node, same point, the behavior of the network node with regard to the external input and output signal. Underline external input and output. External input and output is described by special variables called environment variables, described by special variables called environment variables, such as the position of switch. You can this give the sentence. Okay, in interviews also, if they ask you, you know about environment variable, can you give the example of means, so you can give this. So for checking, it will be like the external input and output signals. It describes by the special variable called environment variables, such as a switch. Okay. So next, so with the help of this, how we are able to access this environment variable with the help of the CAPL scripting. So you are able to see right from the image, the front is a switch, but that backend is it need to interact with the CAPL, and from the CAPL it will make us to access the information. So throughout the globally, okay. So because all these accessible to all events and function in a CAPL program, they are considered as a global variables. Okay, global variables means where we are able to access throughout the program. Okay, so you can write down global variable means we are able to access throughout the program. Okay, is it clear for all? Anyone, can you reply me like yes? You are able to understand what is the interface, how we are making the backend, the CAPL programming, and how it is doing the communication. Okay, so for making to these panels light in higher level, we need to know of some functions. What are those some functions are? Sorry. So get value size, put value. Get is reading, put is writing. So put value to control, enable control, and set control. So these are the some functions. I will share you later on this. So these are the some functions where you need to access. These are the environmental variable functions. And so it is the same like put value, get value. Just I make it in the table in detail, like what is a get value, reading of the value of the environmental variable. Get value size is gets the size of the environmental variable in bytes, and make RGB, so that sets the primary color values. Put values assign a value to the environment variable. So this will be all comes as a part of the environment variables. Okay, is it clear? So let's take one example. So int value is a my uh, uh, declaration, and float is the FEO. This is also one declaration with the weight name, and character we are declaring as a buffer of 25 array. Okay, so now I need to if I need to read the, okay, so I need to read the value so of the switch. So get value bracket switch I need to use like this. So I need to here it's reading the switch position, means whether it is a 0 or a 1. So that value will be reading and it is assigning to the value. Is it clear? So you know about this get value function as I mentioned earlier, and even so you need to give the node name and buffer, and this value will be assigned to the value. Okay, so these are some examples. So let's take it the other example, how in CAPL. So like first you need to go create the DBC file. Okay, so in DBC file, what you need to do? So just to create the environment variables. Okay, so then like a switch environmental switch 0 signal 1. So like this, and these are 7 LEDs. Okay, and similarly you can create the 7 switches. So you need to ensure that the naming and the minimum and maximum values, these are some values. Okay, default you can create the naming. Okay, so next what you need to do, so you need to go to the programming. Okay, so variable, character, and switch the message and the LED. Next what you need to do, on environment variable and if get value this. So when you do this, right, the programming, so this you need you this this is a reference of the environment variable. Here, the environment switch is whatever we created in the DBC file here. Okay. So this is the reference. So if, and next is R equals to, it is not equals to 0, 1, means just on off like this. Okay. And if it is when you press on 1, the switch will on, means it will come green. If not, it will go off, like that it will be. So again, send a request. So like this, this program is created for one switch. Similarly, you need to make it for the other switches also. Okay, this is one exercise you need to do. And next is, generally in interviews they will ask you like, can you write a one program for by using environment variables? So environment variables generally to lock all the doors after the ignition is on before sending a message. This is my requirement for this. I'm writing env variable and ignition switch. Okay, ignition switch is the environment variables. Okay, means this is a switch, right? This is a kind of a physically where we are making on off. Okay, so now when we do this, okay, so means my requirement is to lock all the doors. So set the signal here to lock all the doors. Okay, so whenever uh, it is locked, means this is a reference of the ignition switch. If it is a 1, right? So you know about this is a comparison. If 1 is equal to 1, it is true. Okay, if one is, if it in case it is a switch is off 0, means 1, it is not equal, right? It will be a false. So like this the comparison will do in the if condition. So if it is true, what will happen is, so if it is if it is true, the else part means whatever the condition here, it will be there, it will appear. If not, it will move to the else part. Okay, so this is the if else program. And moreover, the output, it will say that whether the door state message is set to 1 or 0, you will get it in the output. So usually this is like a high level program. So just you need to ensure that whatever the environment were variables, so it will read the, uh, we are specifying this as a part of the external input and output. External input and output signals. Okay, so whatever we are sending, so this will, whenever you mention this, this is referring to the environmental switch, and get value is read. It is reading the environmental switch and it is comparing. If it is true, it will set all the signals to lock all the doors, else it will set the signals here to unlock all the doors. So this is the, if condition is true, it will happen here. If it is a false, it will happen here. And finally, the output message, whether true or false, it will be coming as an output. Is it clear? Okay. So next is, so how we are creating and making the environmental variables. So whenever the value of environment variable changes, when we are updating the switches or those things, so the corresponding environment variable event procedure will be start executing. So how it will execute? There are two methods. So the first method is we are making in the panel with the input output, whatever we are defining, right? So the user defined within the graphical panel, we are making it. And the second way is with the we are using, we need to use some functions. So that is a put value functions. So these are the two event procedures we are following it. Okay, so the examples of this are, so how we can declare and initialize these put values, environment variables. So like when you are writing with integer or float, you need to follow this syntax for the functions, like put value. So what is the value you need to put? Whether it is 100, means it is a write kind of thing. Whether you need to write 100 or 10 to the messages signals, so that you need to give like this. And specifically for get value, you are reading it, so you need to follow this format. So these are the other functions for get value. And parallelly, like this keyword, how we are referring. So whenever you will make the flow rate, environment variable flow rate. So again, the flow rate is reading as the, so there is some sample rate or some signal you need to read on environment variable. So you can make it that information as a flow rate. So this, when you do this, so this is a reference of the flow rate, and that value, whether it is a 1 or 100 or 20, so that detail will be written and stored here. So next, it will display as a part of a output. Okay, so next, I need to read the some data from the message. So what is the syntax I should follow? On message and engine temp. Okay, so this programming I will share you. Okay, so then you can try to understand. Signal temp, like engine temp, if I do it right. So the temp here is just a variable I declared. So this dot long 0. Okay, so I gave in this long 0. When I refer this, right, so it is a reference of the engine temp. Okay, so now whatever the variable I create as a long, so that it means long means this is a data type. Remember, guys, this is a data type. Okay, so just I'm making my this because to ensure whatever the data I'm reading in a the long integer means where I need to get like 1,000 or 800 those values. Okay, in terms of the huge data size, it will be high, right? So that should be reading. And next, coming to the how you need to respond the message after a delay. So here, like the same, like if the message is whatever, you need to declare a timer, and the global variable section is a part of the variables. So as we know, sorry. So here under variable section, we are declaring all the global variables, and this will be the on event. So okay, event means whatever the message door state. If you mention if door is closed, then this statement will be executed. If door is open, else statement will be executed. And whenever we are making to turn off, means this is an example of the automatic of door opening and closing. So whenever you open the door, and when you are entering into the home, how that like light will on, right, automatic. So that kind of example it is. So and creating of the timer, so whenever the actual turn off the light for every 5 seconds or such things. So how we are writing making as a timer within this. So just I showing you example where and all we are able to make the environmental variables, and how we are using those function. So these are some examples. Okay, and moreover, how, let's take this as an example, like for you are transmitting, like you created a two nodes. Okay, two panels are there. One panel it have the LED, and another panel it have a the switch LED. Okay, so the first part will be the switch and the LED display. Okay, so whenever you on, you need to on the LED, and you off, you will off the LED. So how you need to do, the first step is we need to create the program like this, the message LED A, and on environment message LED D. So here whenever you mention this as the transmit, so this is specific to this variable environment LED. So this is the referring. Okay, so the output will be the message whatever you need to send from this node to LED. So whenever you turn on, this message A will be transmitted to the LED. So how the receiver will be, the message LED will be there. So it will make to write. Okay, so this is a put value E environment LED, and this will be reading as this. Okay, so like this, the program will be there for the transmitter and receiver. Did you got it? Did you understand this concept? Because you need to do the assignment. I will share you this assignment for you to practice. Okay, is it clear? So this is a, like a small switch and LED, like how you are able to make the uh, panel creation. Only thing is you need to understand like how we are able to give the environment variables and how you are using the this and get value. Okay, is it clear still now?
Yes, sir.
Whereas parallelly, like we can make a series of the LEDs and the switches, and we can do the practice. Okay, these are some periodic messages, how we need to send, and this all we discussed, and conditional messages. This is a one programming where we need to understand the condition, means specifically like variables, we are declaring the messages, and I am initializing the int. Okay, my int a is 0, means whenever the initial value it is 0. If condition is like this is a toggle, means now initial value is 0, means this is 0, means it will be a 1. Okay, so like consider this is a, so here it is 0, means it is a not, right? Not of 0 is 1. Okay, we know about not gate, no? So not gate is specifically we are sending 1, means it will be 0. If it is 0 means 1. Similarly, when you mention this not, so if it is a 0 means for this value it will be 1. Now if condition is 0, okay, so 0 is equal to 1 means it is a false. If it is a, because it is a comparison, double equal. If it is a true, okay, in programming if you are making single equal, it is a assigning. Okay, just we are making a equals to 1 means a val 1, a value it will be 1. Okay, so if we are making b means it will be 2 value, 2 will be the b. So like this, just it is assigning and doing the comparison. Okay, so and moreover if this condition is true, what will happen, my timer will start. So once the timer is started, then the message will start continuously sending. Okay, so this is a one example how conditionally, if they ask you conditionally, means you need to make some specific if condition and you need to write it. Okay, this is the program you need to understand. I will share you this. So another important interview, they will ask you like, I have created a 2 nodes. Okay, so one node is transmit. Uh, if here I have a message, just consider that message is here, which I need to whenever I will transfer the message A, the message B should be so should be sent. Okay, if I transmit message A to node B, then only the message A should be sent. Okay, if it is not transmitting C and D messages, it should not send. Okay, so how we are doing the specific program where for 2 nodes communication is, so node 1, I have created one message M1, and whenever I will on key, so just I will making the DLC, and we can declare like this also, the DLC, and the signal, my signal value is I created like 90. Okay, so that program like in other node I created like on message, this is a other message, and whenever this signal, what is this signal underscore 1 is matched with 90, then set timer will be activated, then the message will start moving. So this is the 2 node communication, means you need to understand how these signals are inter able to access from one node to the another node, and within the programming. Okay, this is also one important concept you need to understand each and line for the interview. And this is like switch on. Similarly, like you are activating the switch on CANoe, how you are able to send the message signal value. So like if I on the switch, at the rate, we can use the at the rate. So when you, this is a specific to the system variables. Okay, so remember when you are using these system variables, you at the rate, you can see in the capital. Okay, so for environment variables, we are using this as a reference, but system variables, when we need to use, we are using at the rate. So directly you need to give the value. So when you do this at the rate is equals to 1, which means switch is on, means it will be a 1. So 1 is equal to 1 means this data will be sent. Okay. So if it is not, it won't send the data. Okay, means it will be in a 0 0. So else I part also I written. So this is specifically for the system variables programming. Okay, so how we are reading this, the signal value, the other format where we can give the some variables on start and on key, and setting up the value and set the right value. So these are some keywords where we can read the signal values, but with the help of system variables. As I told you, we are making, whenever we are writing system variables are the rate we use. These are like CAPL related, like panel creation. When you doing in high level to understand this, and when you need to do from scratch, right? So these functions will help you to understand the better way. Okay. So there are other functions, means without function, how we can read and set the values in the CAPL. So this is a very important concept here. So to read the value, I need to read the engine speed, okay, engine message. So this is the signal, okay. So message signal, you can write down like this. So set and get signal values, set and get signals values without function. Without function will be two methods. Okay. So first method will be, you can write down how to set. How to set means write. Okay. Write the signal value. How we need to write the signal value. So I need to use the simple assignment dollar of my signal equals to value. Dollar of signal value. Like if I say that um, door lock is my signal. Okay. So I will say that 1. Okay. My door will be locked. Just it is, we are writing it. Okay. So this is a door without function. Remember, this is a, in interviews they will ask you without function, in CAPL, what are the sign you use? So sign my value, my signal equals to value. And dedicated function, yes, with function we are using like this, set signal, my signal and value. This is with function. Okay. So, and the other part will be like this is the signal. Okay. It's engine underscore coolant underscore temp equals to 1. So this signal will read the continuous temperature value. So until greater than 150 degrees. So once it reaches, it will be stopped. So like these are small examples, like how we are declaring the dollar of signal means it is a reading. Okay. Sorry, it is writing. Yeah. And next is uh, the get value. So you can write down this also, get int value. When you declare dollar a dollar followed by the signal that is equal to the value, it is a kind of a assignment means assigning the values. Okay. We are allocating it. Okay. Is it clear? So these are few things you need to understand. I will share you this screenshot later. And next is, so whatever we discussed, the environment variables and system variables. So just it is a overview. Environment variables will be the external IOs. Okay, so that external IO signals, and system variables are the internal parameters. So that are indicated in the CANoe. Okay. And there are some other points. What are the set environment, get environment will be the part of environment variables. And moreover, the system variables are its system level parameters and properties. Okay. So these are a few things. Yeah. Like these are covered as a part of our practical questions. Okay. So you can go through this, and the final will be the UDS, so diagnostics. So once our UDS concept completes, like diagnostic, how you need to identify the faults or failures in the system, in the cars or those things. So with the help of the CAPL, how we're able to read the information, all will be covered once after those concept is completed. So this is a UDS capital scripting. How we are sending the request, and tell you the two things here. Just read it. You have a brief information here. So introduction of CAN-DBC, here lab 2 you have, and we have a lab 1. Okay. So lab 1, it talks about what is the functions of CANoe, how you need to do what in brief info you have. And next lab 2, you have a CAN-DBC, how you need to create the network, how you need to configure those, it will be there. And next will be the panel editor. So in panel editor, what you need to do exactly, you have the info. So in the CAPL, what are the what are the major difference in the CANoe and in the CAPL browser? So that will be there here, just the brief info. And so here the actual assignment will start here. The first assignment is you need to create the networks, 3 networks and 3 messages and 4 signals. Okay. So next, you know what you need to do. You know how to assign the signal to the message, right? So you need to assign like this. Next, you need to go to the environment variables and panel editor. You need to create the switch button and LCD buttons. Okay. Next, step 3. So you should follow the random numbers and you need to give it. So I given the brief information. This is a one assignment activity you can try. So before trying this assignment, right, it is clearly it is mentioned what you need to do one after the other. Okay, you need to spend some more time on you need to do. So my suggestion will be first take this as a priority. Okay, so what you need to do, so here it mentioned clearly what are the steps you follow. This create a database, create the node and database associate database, create the panel, next place the panel into the CANoe environment, create a node. So step by step you can go through it. Okay, so like how you need to create the messages and take this area as a same. Like if you need to change the name of a switch, or you can change, you can give your name also, that's fine. But my suggestion will be go with the first with the document defined. Okay, so next step will be like first create the DBC. Next, after creation of the DBC with the switches and indicators, the steps are clearly it is there. Go one by one. Okay, so spend this is a part of a real-time walking. Okay, so when you need to create some panel, you need to do the same process. Okay, so for understanding, you will also get hands-on experience how you need to create the panel. Okay, and same with the environment variable, how you are able to access this. So in DBC, you are able to see the DBC, it's created environment variables, network nodes, messages and signals. So now you need to access them like environment variables are this many, like switches, indicators we have, and messages, it is for the interaction. Okay, so go to the CANoe and add the switches and indicators. These are the steps it given. So like my switch is there, indicators is there. Whenever I will turn on the switch, the indicator will glow. So these steps are there in detail. Please try to practice this. This is a whenever we start our electronic career, right? We'll always start with the LED. Okay, to ensure that we are making something to work. Okay, so similarly, you can follow this process in the document I mentioned. Okay, here you have the CAPL also, the programming, what you need to write. So just it is defined. You need to ensure that programming should be followed in such a way. Then your panel is ready. Okay, is it clear? Any doubts you have on this? Any doubts? You can follow, right?
Yes, sir.
Yeah, try to do this. Okay, so mostly it will help you to understand how you need to create the panel. Like seat, you need to create, right? You know how the seat is moving, how you need to make the graphical movement. So all this information you will get it familiar. Okay, this is a panel creation. This is for a development activity. Okay, so panel creation is a next level. Okay, and moreover, means it will give more weightage to your profile. That's it, nothing else. But if you learn, it will be well and good. Okay, so that's it my end. Is there any questions we can discuss in tomorrow class also? So tomorrow we'll go with the queries and discussion. If you are facing any issue on the CANoe tool or CAPL, something is not working, we'll discuss it and we'll clarify it. Okay. Yeah, that's it from my end. If you have any points, we can discuss it. And I will share you the important slides, make a notes, and the programmings also I will share you, make a notes on it. Okay. Is it clear? And I will share you this document. This document, follow this document and try to create the panel. Okay, this is the assignment activity for you. Yeah, that's it from my end.